Understanding the wiring and protection of a powered rail system for cranes and trollers is crucial for safety and proper operation. Let's address the concerns about wiring, protection, and ensuring a correct installation. Firstly, regarding whether it is a true parallel connection, it can be considered a true parallel connection if specific conditions are met. 1. The flat copper buses and the 3 number 10 wires for each phase must have equal resistance. 2. The load must be evenly distributed across the 3 phases. This ensures that each wire carries its intended share of the current. Secondly, protecting the number 10 wires correctly is of paramount importance. These wires should be protected by both overload and ground fault protection devices. For overload protection, each number 10 wire should be protected by a 30 amp circuit breaker. There are 2 ways to achieve this. 1. You can use a multi-pole circuit breaker. 2. You can install individual circuit breakers for each wire. This ensures that if any single wire exceeds its 30 amp rating, the circuit breaker will trip, preventing overheating and potential fire hazards. For ground fault protection, a ground fault protection device should be installed on the system to protect the number 10 wires from ground faults. This can be achieved using a ground fault circuit interrupter, GFCI, or a residual current device, RCD. These devices detect any leakage of current to ground and quickly interrupt the circuit, minimizing the risk of electrical shock. Now, let's address what else you need to do to make this a correct installation. In addition to protecting the number 10 wires, several other factors should be considered to ensure a correct and safe installation. 1. Insulation. The plastic rail and the number 10 wires must be properly insulated to prevent electrical shocks. Inspect the insulation for any signs of damage or wear and replace it as necessary. 2. Grounding. The system must be properly grounded to protect against electrical hazards. Ensure that all metal parts of the system are connected to a common ground point, providing a path for fault current to flow back to the source and trip the circuit breaker. 3. Documentation. The installation should be thoroughly documented, including the electrical schematic, wiring diagrams, and specifications. This documentation will be invaluable for future maintenance, troubleshooting, and inspections. Furthermore, additional considerations should be taken into account. The 125 amp feed from the breaker to the rail connection box should be protected by a 125 amp circuit breaker. This protects the entire feeder circuit from overcurrent conditions. The number 10 wires should be securely connected to the connection box using approved connectors. Proper connections minimize the risk of loose connections, which can cause overheating and arcing. The powered assembly should be properly bonded to the system ground to ensure electrical safety. This prevents the powered assembly from becoming energized in the event of a fault. In summary, ensuring equal resistance in the parallel connections, providing both overload and ground fault protection for the number 10 wires, proper insulation, grounding, thorough documentation, and addressing the additional considerations will lead to a correct and safe installation of the powered rail system. Always consult with a qualified electrician to ensure compliance with all applicable codes and regulations. Understanding the NEC is paramount. For example, Article 310.15 addresses ampacity and temperature limitations. Table 310.16 provides ampacity ratings for conductors based on insulation type and ambient temperature. When dealing with parallel conductors, NEC Section 310.10 paragraph H outlines specific requirements. Firstly, all parallel conductors must be the same length. Secondly, they must have the same conductor material. Thirdly, they must be the same size and circular mill area. Fourthly, they must have the same insulation type. And fifthly, they must be terminated in the same manner. Regarding overload protection, the overcurrent protection device should be sized according to NEC Section 240.4, which specifies the protection requirements based on conductor ampacity. Ground fault protection is covered in NEC Article 230.95 for services, and similar principles apply to separately derived systems or feeders supplying the crane rail. The goal of ground fault protection is to detect and interrupt low-level ground faults that may not trip a standard overcurrent device. thus reducing the risk of arcing faults and equipment damage. It is important to consider the voltage drop in the system. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. NEC Section 210.19 Paragraph Number 1, Informational Note Number 4, provides guidance on voltage drop limitations. Typically, a voltage drop of no more than 3% for branch circuits and 5% for feeders is recommended. Ensuring that all electrical components are properly listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories UL, is critical. This indicates that the equipment has been tested and meets applicable safety standards. Properly torquing all electrical connections is essential to prevent loose connections and overheating. Use a calibrated torque wrench to tighten connections to the manufacturer's specified torque values. Regularly inspect the electrical system for any signs of damage, wear, or corrosion. Address any issues promptly to prevent potential hazards. Consider the environmental conditions in which the crane rail system will be operating. Factors such as temperature, humidity, and exposure to chemicals can affect the performance and lifespan of electrical components. Select components that are suitable for the specific environment. Coordination of overcurrent protective devices is crucial to ensure that only the affected portion of the circuit is interrupted in the event of a fault. Conduct a coordination study to determine the appropriate size and settings for circuit breakers and fuses. Providing clear and legible labeling for all electrical components and circuits is essential for safety and ease of maintenance. Use durable labels that are resistant to fading and weathering. Ensure that all personnel who will be working on the crane rail system are properly trained in electrical safety and safe work practices. Provide ongoing training to keep them up to date on the latest codes and regulations. Implement a lockout-tagout program to prevent accidental energization of the electrical system during maintenance or repair work. Follow the procedures outlined in OSHA Standard 29 CFR 1910.147. Consider using surge protection devices to protect sensitive electronic equipment from voltage surges caused by lightning or other electrical disturbances. Surge protection devices should be installed at the service entrance and at downstream locations as needed. Regularly test ground fault protection devices to ensure that they are functioning properly. Follow the manufacturer's recommended testing procedures. If the crane rail system is located in a hazardous location, such as an area where flammable gases or vapors are present, ensure that all electrical equipment is rated for use in that hazardous location. Follow the requirements of NEC Article 500 through 516. Consult with a qualified electrical engineer to design and review the electrical system for the crane rail. An electrical engineer can provide valuable expertise and ensure that the system meets all applicable codes and regulations. Keep detailed records of all inspections, testing, and maintenance work performed on the crane rail system. This documentation will be helpful for tracking the performance of the system and identifying any potential problems. Ensure that the crane rail system is properly maintained to prevent electrical hazards. Regular maintenance should include inspecting wiring, connections, and components for any signs of damage or wear. Consider using energy-efficient electrical equipment and practices to reduce energy consumption and lower operating costs. For example, use LED lighting and variable frequency drives for motors. Stay up to date on the latest revisions to the NEC and other applicable codes and regulations. The electrical codes are constantly evolving to reflect new technologies and safety practices. When installing the 1/0 wire from the breaker to the rail connection box, ensure it is properly supported and protected from physical damage. Use appropriate conduit or cable trays to route the wire and secure it with approved fasteners. When making connections to the copper bus bars, use properly sized and rated lugs and connectors. Ensure that the connections are clean, tight, and free of corrosion. Consider using an anti-oxidation compound to prevent corrosion. When running the number 10 wires, ensure that they are properly bundled and supported. Use cable ties or other approved methods to keep the wires organized and prevent them from becoming entangled or damaged. When terminating the number 10 wires, ensure that they are properly stripped and terminated with appropriate connectors. Use a crimping tool to ensure a secure and reliable connection. When selecting circuit breakers, ensure that they are properly rated for the voltage, current, and interrupting capacity of the circuit. Use circuit breakers that are listed and labeled by a recognized testing laboratory. When installing ground fault protection devices, ensure that they are properly sized and installed according to the manufacturer's instructions. Test the devices regularly to ensure that they are functioning properly. When grounding the system, use a grounding electrode system that meets the requirements of NEC Article 250. Ensure that the grounding electrode system is properly installed and maintained. When documenting the installation, include detailed wiring diagrams, equipment specifications, and calculations. Keep the documentation in a safe and accessible location. When training personnel, provide them with hands-on training and practical exercises. Ensure that they understand the hazards of electricity and how to work safely around electrical equipment. When implementing a lockout-tagout program, follow the procedures outlined in OSHA Standard 29 CFR 1910.147. Ensure that all employees are properly trained in lockout-tagout procedures. When using surge protection devices, select devices that are properly rated for the voltage and current of the circuit. Install the devices according to the manufacturer's instructions. When testing ground fault protection devices, follow the manufacturer's recommended testing procedures. Record the test results and take corrective action if the devices fail to function properly. When working in hazardous locations, ensure that all electrical equipment is rated for use in that hazardous location. Follow the requirements of NEC Article 500 through 516. When consulting with a qualified electrical engineer, provide them with all relevant information about the crane rail system. This will help them to design a safe and reliable electrical system. When keeping records of inspections, testing, and maintenance work, include the date, time, and name of the person who performed the work. Also, include a description of the work performed and any findings or recommendations. When maintaining the crane rail system, follow the manufacturer's recommendations for maintenance and repair. Use only approved replacement parts. When using energy-efficient electrical equipment, select equipment that is properly rated for the application. Ensure that the equipment is installed and operated according to the manufacturer's instructions. When staying up to date on the latest revisions to the NEC, subscribe to industry publications and attend continuing education courses. This will help you to stay informed about the latest changes to the electrical codes. Consider using a power quality meter to monitor the voltage, current, and power factor of the electrical system. This can help you to identify any potential problems with the system. Regularly inspect the crane rail system for any signs of wear or damage. Replace any worn or damaged parts promptly. Consider using a thermal imaging camera to inspect electrical connections for hotspots. Hotspots can indicate loose connections or other problems that can lead to electrical failures. Ensure that all electrical equipment is properly ventilated to prevent overheating. Do not block ventilation openings. Consider using uninterruptible power supply apps to provide backup power to critical equipment in the event of a power outage. Ensure that the UPS is properly sized and maintained. Consider using a harmonic filter to reduce harmonic distortion in the electrical system. Harmonic distortion can cause equipment to malfunction and can also increase energy consumption. Ensure that all electrical panels are properly labeled with the circuit numbers and descriptions. This will make it easier to identify and troubleshoot circuits. Consider using a programmable logic controller, PLC, to control the operation of the crane rail system. A PLC can provide precise and reliable control of the system. Ensure that all electrical components are properly shielded to prevent electromagnetic interference, EMI. EMI can cause equipment to malfunction and can also interfere with communication signals. Consider using a surge arrestor to protect electrical equipment from lightning strikes. Surge arresters should be installed at the service entrance and at downstream locations as needed. Ensure that all electrical equipment is properly lubricated to prevent wear and corrosion. Follow the manufacturer's recommendations for lubrication. Consider using a power factor correction capacitor to improve the power factor of the electrical system. Improving the power factor can reduce energy consumption and can also improve the voltage regulation of the system. Ensure that all electrical enclosures are properly sealed to prevent the entry of moisture, dust, and other contaminants. This is especially important in harsh environments. Consider using a ground resistance tester to measure the resistance of the grounding system. A low ground resistance is essential for electrical safety. Ensure that all electrical conduit is properly supported and secured. Use approved conduit hangers and fasteners. Consider using a cable management system to organize and support electrical cables. This can help to prevent cables from becoming tangled or damaged. Ensure that all electrical work is performed by qualified and licensed electricians. This will help to ensure that the work is done safely and correctly. Regularly review the electrical safety procedures and practices with all personnel. This will help to keep them aware of the hazards of electricity and how to work safely around electrical equipment. By following these guidelines, you can ensure that the powered rail system for cranes and trolleys is wired and protected correctly, and that it is installed and operated safely. Remember to always consult with a qualified electrician or electrical engineer for specific guidance and to ensure compliance with all applicable codes and regulations.